So in the last session, we started discussing about inter-process communication methods. So there we discussed about one important method, that is message queue. Okay, so in the message queue, we discussed what are the different methods or APIs used for sending the messages. Okay, so message send function, message control function, and message receive function. So today we'll discuss about Semaphores. Okay, so Semaphores is a counter used to provide access to a shared data object for multiple processes. So this is also one of the method for communication between the process. Okay, so here what we do is we have a data structure where we keep the shared data. So this data can be shared by multiple processes. Okay, so they can exchange the data by using this shared data object. So to obtain shared resources, a process need to do the following thing. Okay. So to exchange the data among the process need to do few things. Okay. So there are 3 points we will be discussing. So the first thing is test the semaphores that controls the resource. Okay. So here we need to know that the Semaphores, that is inter-process communication method, has all the control over the resources. So it may be the process may need access to a file, or it may need access to a memory location, or any type of resources. Make sure that this inter-process communication method has access to all the resources that might be necessary for exchanging between the process. Okay. The next point is, if the value of the semaphores is positive, okay, so if the semaphores returns positive value, then the process can use the resources. Okay, positive value means yes, everything is fine. The process can start using the resources. In case, okay,
Ma'am,
process, yeah.
the slide is not visible, ma'am.
Okay. Now is this fine?
Yes, ma'am.
Okay. So we were discussing about the Semaphores. Okay. So Semaphores is a process, okay, in the inter-process communication method where we will be using the shared data which can be used by multiple processes. Okay. So what the process must do, the first thing is test the Semaphores that whether it have access to all the resources. If it has access to all the resources, then it returns a positive value. It returns positive value. Okay, then the process decrement the semaphores value by 1. Okay, every time it decrements the value by 1, indicating that it has used 1 unit of the resource. Okay, a certain process, for example, if I have 5 process, every 5 process will be allotted with the amount of resource it can use. Okay, amount of units of resource it can use, for example 5 unit of resource. Okay, maximum, for example, if P is a process, P can use only 5 unit of resource. Every time when it make use of this resource, the value will start decrementing. So initially 4, then 3, 2, and 1. Okay, finally when it becomes 0, okay, when the value of the semaphores becomes 0, process goes to sleep. That means it will not have any access to the resource. Okay, and it will be in the sleeping state until the semaphores value will become greater than 0. Okay, so once the value becomes greater than 0, then it will understand that yes, it has the right to access the resource. Okay, when the semaphores wake up, it turns to step 1. Okay, again this procedure continues. Okay, so these are the 3 steps in the semaphores that is required uh, to obtain a shared resource for a process. Okay. So sometimes they may ask you for 3 or 4 marks, what are the steps required or what are the steps the process need to follow to share the resources. Okay. So these are the steps. Okay. So when the process is done with the shared resource that is controlled by the semaphores, okay, semaphores value is incremented by 1. Okay, after that what happens? Once it will get the value greater than 1, greater than 0, again the process, okay, the value will start increasing by 1. So there are different types of semaphores. So here we'll be discussing two types of semaphores. One is binary semaphores and another one is system V semaphores. Okay. So these are the two types of semaphores we are going to discuss. So the most common form of semaphores is binary semaphores. Okay. So what is this binary semaphores? So in the binary semaphores, it controls a single resource. Okay. So its value is initialized to 1. So here it will have how many resources? It will have a control on only a single resource. Okay. So okay. So this is a type of semaphores. Next one is, okay. So in general, however, the semaphores can be initialized to any positive value. Okay, in generally it can be initialized to any positive value. Here I have said 5 units. Okay, like that it can be assigned with any number of units of resources, which indicate how many units of shared resources can be available for the for sharing. Next type of semaphores is system V semaphores. Okay. So it is actually it's the most complicated form of semaphores. Okay. So three features contribute to this unnecessary complications. Okay. What are the features that we have under the system V semaphores? These are the 3 points under system V semaphores. So three features. The first one is semaphores is not simply a single non-negative value. It does not have just a simple positive value. Okay. When we create a semaphores, it will specify the number of values in the set. Okay. So in binary, we said that it will be having only one initial value. I mean, how many units of resource it can use, only that value it will be having. But here, we will not have just one single value, but instead we will be having number of values. Okay. So there will be, okay, uh, there will be a set of one or more semaphores values. Okay, we'll see what are the values later. Okay. Next, the creation of semaphores. Okay. So if you want to create a semaphores, we need this function. So this is a function which we'll discuss later. Okay. Is independent of its initialization. Okay. So for to get the semaphores, we'll be using this function, and for initialization of the semaphores, that means we are having number of values, right? So that values to be initialized, we'll be using this function. Okay. Similar to your message queue. So in the message queue, we have used control, receive, and send functions, right? Same way here also we'll be having different functions. Okay. So here, okay, so these are the two important functions that is required. Since all form of system V IPC remains in existence even when no process is using them. Okay, so whatever the inter-process communication, okay, uh, the, uh, the functions, whatever the semaphores you have created, okay, for the communication between the process, that remains in the system, okay, when a certain process deletes it. Okay. So so we have to worry about the program. So we need to think, okay, what program can be used that terminates without realizing that semaphores it has been allotted. Okay, we need to think. Okay, once it is allotted, programmatically you have to write the program for deleting the unused semaphores, which is not necessary anymore for the communication between the process. Okay. The undo feature that we described later, okay, is used for handling this deletion or termination of the unused semaphores. Okay. So these are the 3 points. First thing is in binary we have only one value in binary semaphores, whereas in system V semaphores we will be having number of values. Next we need several functions for creating and initializing of the semaphores. Next, we have to think how to delete the unused semaphores once the task is done. So these are the three things we need to take care in system with semaphores. Okay. Next, similarly, we have discussed about message queue data structure or structure. Here, kernel also maintains a structure for each semaphore. So we said that for communicating between the process, we can have any number of semaphores. Okay. So each of the semaphores will be making use of this structure, which is a built-in structure. Okay. So who will maintain the structure? This structure is maintained by the kernel. Unix kernel will be maintaining this structure. Okay. So what are the things we have in the structure? So we have this again one more structure, that is sem underscore permission. Okay. So sem underscore permission here, that is meant that is used for here. Okay, this is for permissions. Okay. So this is for the structure will have all the initialization of the permission, that is affect user ID, real user ID, or any mode of communication. Everything is there in this permission structure. Next, we have one more structure, that is system underscore base. Okay. It's a pointer to the first semaphores in the set. So we can have between the process, we can have any number of semaphores. Okay. So the first semaphores will be having this pointer. Okay. Next, unassigned sign short sem and semaphores. So this is a member in the structure which will be having the number of semaphores in the set. Okay, whether we are having 2 semaphores, 3 semaphores, how many semaphores we are having. So this is giving the number of semaphores in the set. Next, again we have two time members. Okay, so this time members will be having two things. One is the last semaphores time, okay, or last change time. Okay, so these two things are for maintaining the time informations. So here this is a pointer, as I said, it will be pointing to the memory in the kernel. Okay, memory in the kernel. Okay, we said that in the semaphores we are using shared memory, correct? The process will be using some shared data. So this pointer will be pointing to the memory of the kernel, memory in the kernel. Okay. Kernel which is used for sharing the data. Okay. So this memory in the kernel can be is pointed by this pointer, okay, pointer which can be used by multiple processes for communication. Uh, next, next we have one more structure here. Okay, so that is an array of sem structure containing, okay, n sem, that is this one. Okay, sem n sem, okay, elements, one element in the array for each semaphores values in the set. For each semaphores in the set, we said there are can be a number of semaphores in the set. For each semaphores in the structure, we will be maintaining this structure. Okay, again, this is one more structure. Okay. So you can see here what are the things we have in this structure. We have sem value. Okay, sem value is the semaphores value. So we can say that one semaphore can be having multiple values. Okay. So here this sem value will be having semaphores value. So always value should be greater than or equal to 0. Okay. Next one is sem PID. So PID is nothing but process ID for the last operation. Okay. Next one is unsigned start. Okay. Here it is. This is one more field, that is the process awaiting, okay, for some value greater than current value. There is one more, that is last member. Here this is a process waiting for stem value to be equal to 0. Okay, so these are the different structure fields or members. So let us start discussing about the functions. Okay. So in the message queue we have discussed different functions. Similarly, here also we'll be discussing different functions. You may get the question like explain Semaphores and what are the functions we have in the Semaphores for creating the function or for communication. Okay. So the first function we are going to discuss is function to call, that is system get, Semaphores get, which is used to create or to obtain the Semaphores ID. So previously we discussed in the message queue. Okay, just show you here. We have used this message get, right? This is also used for creating the message queue and for getting the ID. Okay, it returns a non-negative message queue ID. Similarly, here also we are using the function that is semGet. Okay, so semGet is also used for getting Semaphores ID. Okay, it is used for creating the Semaphores. Once you create the Semaphores, this function will return the Semaphores ID. Okay, it will return the Semaphores ID if everything is fine, or it returns -1 on error. Okay. So this is a header file we are using, sem.h. Okay. There are two parameters. One is key, okay, and next we have nsem, okay, number of Semaphores, and flag. Okay. So if you remember last session we discussed that we need a key. Okay. Once we know the key, okay, every key will be converted into ID by the kernel. Okay. So we have described how the key will be converted into ID. Correct. If you remember, I have shown you the steps how to convert the key into ID. Okay. So we need to follow all that rules for converting the key into an identifier. Okay. And so so here the key will be converted into ID. Okay. So when a new set is created, the following members, okay, when a new Semaphores is created, a following members of this structure, that is this structure, okay, the structure, following members will be initialized. So here, what are the things that is going to initialize? First one is this. Okay. So permission will be getting initialized. So this is structure, that is sem underscore permission. So that permission field will be initialized. So here in this permission field, we will be having different permissions like real user permission or effect user permission, mode. That is a mode. The member of the structure is set to the corresponding permission bit of the flag, read mode or write mode. So next we are going to set O time. Okay. And similarly, we are going to set C time to the current time and nsem to the number of Semaphores. Okay. So nsem is nothing but the number of Semaphores to be set. How many Semaphores? For communicating between the process, how many Semaphores? 2 or 3 or 4 Semaphores? How many Semaphores have to created? So that can be given here in the nsem, I mean Semaphores. Okay. So So this is the first function for creating the Semaphores. Okay. So the next method that we are going to discuss is, next function is Semaphores control. Okay. So this function is a catch-all for various Semaphores operations. So this is used for performing different Semaphores operations. Okay. So here we have different arguments. Okay. The first thing is the Semaphores ID. So Semaphores ID will be returned by this function. So first we have to execute this function. So after executing this function, we will get an ID. So that ID will be used as a first argument. Okay. So this is the first argument, which is nothing but the Semaphores ID. Okay, and apart from that, this is the number of semaphores, and we have some command which we'll discuss later. And again, we have a union semaphores argument. Okay, that is nothing but this union. So there are four arguments. So here, this is a union. Okay, so this is a union. That is fourth argument is a union, which is used for setting different values. So that is for setting the semaphores value and for setting uh, star buffer, which is used for this command. Okay, so this is IP stack. Okay, so this is a buffer that is used for this command. I'll tell you this command. Okay, then next we have this array pointer, which is used by this command get all. Okay. So so these are the union. This is a union with the different members, which is used along with this the third argument, that is command argument. Okay, so these two are interlinked. Okay, so I will start discussing about the current argument. So current argument, command argument. Okay, command argument can have one of the following 10. Okay, here we have already how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more is there. There are altogether 10 commands. Okay, we have 10 commands to be performed and this on the set of specified by the Semaphores ID. Okay, once the Semaphores ID is done, we can perform this 10 commands, or we can tell we can perform this 10 operations. Okay, the 5 commands that refers to one particular Semaphores value. Okay, use the Semaphores number to specify one member of the set. Okay. So here so this is Semaphores number. Okay. So this Semaphores can create how many? It can create different 10 Semaphores. Okay. So how many numbers you can have? Here we can have maximum 0 to 10. Okay. 0 to 10 means 0 to 9. Okay. So 0 to 9, each one will be having their own Semaphores number. So this is having 0, 1, 2, 3, 4, so on. The last one will be having number 9. Okay, so that is the Semaphores number. Okay, so this is the command number. Okay, so here the value of Semaphores number can be, so this Semaphores number can be between 0 to number of Semaphores minus 1. Okay. So number of Semaphores, it differs. Okay, so this Semaphores you can have uh, like this. There are 10 Semaphores. Okay, so this 10 types of Semaphores can, like this, you can create 5 or 6, or depending on your requirements. Okay, so here let us start discussing this Semaphores commands. Okay, so first we will discuss this first one. So first we'll discuss IPC stat. So this will discuss first IPC stat. So IPC stat, it is used for fetching the Semaphores DS structure of the set and storing it in the structure pointed by the argument, that is this buffer. Okay. So this is a buffer. So why it is used? This command is used for setting, okay, this structure, that is Semaphores id.ds. Okay. So fetching all these values. If you want to fetch all these values, okay, we can make use of this first command. Okay, this is the first command we are going to discuss. Stat. And where it will be copied? It will be copied to the this particular structure which is pointed by the buffer. So copy the member of Semaphores ds structure of the Semaphores set to this sem id into this argument, that is buffer. Okay. So it is used to fetch all these values, permission or number of Semaphores, pointer to the first Semaphores, different times, everything can be set, can be fetched by using this first command. Okay, sometimes we may require to get the information about the Semaphores, right? So in that case, we can make use of this. Okay. So next one is, second one is this, we are going to discuss IPC set. So this is used to set the following three fields of the structure pointed by the argument buffer in the structure associated with the set. So here we are used to, the set is used for setting the permission. Okay. So we said that we are having this permission here, right? M underscore permission. So what are the permission values you can set? So here we can set three types of permission by using this second IPC set command. So what are the three permissions? So here we can set three permission. So first one is Semaphores user ID. Okay, effective user ID. And next one is group ID, Semaphores group ID. Okay, you can set this. And the last one is mode. Okay, user ID, group ID, and mode. So these three things can be set by using this second command, that is IPC set. Okay. So again, to set this three things, you need super user privilege. Okay. Third one we are going to discuss is this. Okay, IPC RMID. So this is a command that is used to remove the Semaphores set from the system. So this R stands for removing the Semaphores set. Okay, if you want to delete the Semaphores, okay, we can use this, which is identified by this Semaphores ID. So every Semaphores will be having unique Semaphores ID. Using this Semaphores ID, you can delete the Semaphores, okay, from the system. And the next one we are going to discuss is, fourth one is get value. So get value returns the value of the specified Semaphores element. Okay, returns the value of the Semaphores value of the member, Semaphores number. Okay. So any Semaphores value you can get. Return the value of the specified Semaphores element. Okay. So we said that Semaphores will be having different set of values. So we can get the different values by using this. Next one is set value. That is the fifth one, set value. So this is to return or get the value. This is used for setting the values of the Semaphores. Okay. So this is used for setting the values. Okay, that is by using this array. Okay, using this array, okay, we can get or set the values of the Semaphores. So to specify the values, we are using this. Okay. So this is number, yeah. Next one is the sixth one we are going to discuss is get PID. So get PID is returns a process ID of the last process to manipulate the element. Okay. So here it returns the process ID, okay, which is the last process which has used this Semaphores or modified the values of the Semaphores. So that is get PID. Next one is, seventh one is this one, get NCNT. Okay. So this returns the value number of process waiting for the element to increment. Okay. So returns the value of number of process. Okay. So how many process is waiting for to use a particular Semaphores. Okay. And the next eighth one, we will discuss this eighth one. So get ZCNTL. So it returns the number of process waiting for the element to become 0. So here we said that the process can be incremented with the value, okay, or it can be decremented with the value, or sometimes it also will become 0 when it has, so at the point when it becomes 0, it will go to the sleep state. Okay, so number of process is waiting to go for the sleep state. Okay, so how many process is waiting to become 0? Okay. So it doesn't want to use any resource. Further, it doesn't want to use any resource. How many process we are having? Okay, in the set for not using any resource. Okay, they are done with all the work. So how many process are we are having in the system which don't want to use any resource? Okay, so that is the next one. Okay, so this Z indicates 0. Yeah, and and there is one more. Get value and set value. So set the value of the Semaphores and this is to set the value of the 6 Semaphores elements. Okay, I hope you are done with all these commands. Okay, so give one line explanation of each of these commands. So this is about the command argument. Okay, so command arguments and this union is connected, and this command argument can be used to fetch or set different values or to get or set the permissions. Okay. So the next function we are going to discuss is SemOp. So Semaphores OP. So automatically performs array of operations on a particular Semaphores set. Okay, array of operations. So here this is a prototype. Okay. So here we need Semaphores ID. We are having a array, okay, which is of type structure, okay, sem buff, okay. Then we are having size t n ops. Okay, there are three arguments. So this is the structure. Okay. This is the ID. This is the Semaphores structure. Okay. And here uh, structure is of type array. Okay. So array Semaphores OP array is a pointer to the array of Semaphores operation. Okay. So this is an array of Semaphores operation. It's a pointer. Okay. Next we have NOPS. NOPS specifies number of operation in the array. Okay. How many types of operation or a number of elements in the array. Okay. And here in the structure, what and all we are having? Semaphores number. Okay. So numbers in the set can range from 0, 1 to number of Semaphores minus 1. Okay, so this can have the value between 0 to number of Semaphores minus 1. Then SemOp is nothing but operation, so which can take the value positive, negative or 0. Next, Semaphores flag, which can take two values, either this or this. We'll discuss later about this. Okay. Uh, then here, so as we said that Semaphores value can be positive. Okay. If it is positive, then it corresponds to the returning of the resource by the process. Okay. The value of Semaphores OP is added to the Semaphores value. Okay. Suppose if the value is okay, so positive means it will give you the information about the resources. Okay, what are the different resources the process can use? So it will give you the information about the resources that can be used by the process, okay, for communication. Negative means, okay, suppose if it is negative, this means we want to obtain resources that the Semaphores control. So this negative means the resources are not ready. Okay, so resources are not ready, waiting for the resource. Okay, we are waiting for the resource to obtain the resource. So if the value Semaphores value is greater than or equal to the absolute value of Semaphores OP, okay, the absolute value is subtracted from the Semaphores value. Then suppose if the value is 0, suppose if the value is 0, this means that we want to wait until the Semaphores value becomes 0. Okay. So this means 0 is nothing but we cannot allot any resources. Okay. So here it is allotted with the resource. It is ready to allot the resource. Here it is allotted with the resource. Okay. Here it is allotted with the resource. Okay. If it is positive. Okay. Here means it can allot the resource, but it is waiting for the resource. Okay. But 0 means what? We cannot allot any resource. Okay. But we can allot the resource only if the Semaphores value becomes 0. Only if it is going for the, it is waiting for the sleep. 0 means what? It is in the sleep state. Okay. Yeah. Semaphores is in the sleep state. If the Semaphores value is currently 0, the function returns immediately. Okay. So this is in the sleep state. If the Semaphores is in the sleep state, then it will be having the value 0. Okay. So there are two types of flag, that is no wait and undo. Okay. No wait is specified, and no wait is a flag which is returned when there is any error. Okay. So we said that when we are waiting for the resource, okay, sometimes it may return with this flag, no wait. So no wait means it cannot be allotted with any resources. Okay. So similarly, we have Semaphores undo. Okay, this is one more flag. Okay, to undo any operations. So here, so these are the things. Okay, about the Semaphores. So in the Semaphores, we discussed basic thing of Semaphores, two types of Semaphores. What are the different types of Semaphores? Then we discussed different structures in Semaphores and three types of function. One is to create the Semaphores. Next for various operations and for array of operations. Okay, three types of functions. Okay, so this is the second type of inter-process communication. So next one is shared memory. Shared memory we will discuss in the next class.